Okay, here we have a question where we have a function, it's actually a cubic function, and it says find the x-intercepts. So a couple things to think about. First of all, what is an x-intercept? Well, we know an x-intercept is the point on a graph when it crosses the x-axis. So what's special about that point, no matter where it is, the y value, or f of x, equals 0. So I'm just going to start by replacing f of x with 0, because we know that if we can set that to 0 and solve for x, then those must be the x-intercepts. Perfect. Minus 12. Okay, now because cubic functions are pretty difficult to factor, we're going to use the factor theorem to basically come up with our first bracket that can factor out of this expression, and then we can use long division to solve for the rest. So how do we kind of start, and how do we test which value to even try for the factor theorem? You go straight to the last term. So the last term in this function of the constant is minus 12. So we know, because it's called the factor theorem, we know that we're going to use any factor or number that actually multiplies into negative 12 to test in the equation. Now if we think about any of those factors, basically what we're going to do is we're going to take that number, replace x in this equation with that number, and if it actually works out that it comes out to 0, then we know that that is one of the factors of this cubic expression. I know that sounds a bit confusing, but let's just start with x equals 1. Because we know 1 is a factor of every number, including minus 12, I'm just going to test f of 1. And we'll see what we get. So I'm just going to replace the x everywhere I see it with 1. So it's 1 cubed minus 9 times 1 squared plus 20 times 1 minus 12. What does this equal? 1 minus 9 times 1 is 9 plus 20 minus 12. 1 minus 9 is negative 8 plus 20 is 12 minus 12. Look at that, it's 0. So what did we just show there? We showed that when x is 1 in this equation, this function we're given, y is 0, or f of x is 0. So we know that 1, 0 is a point on the graph. Since 0 is the y-coordinate, we know that 1 is one of the x-intercepts. So we've already got one of our answers. Now, if we think about this equation in factored form, and 1, when x is 1, gives 0, we know now that x minus 1, as a bracket, has to be a factor of the original equation. So just stop and think about that for a second. We found that when x is 1, y is 0. Therefore, when we factor the cubic function and get it into a couple of brackets multiplied to each other, we know that x minus 1 is going to be one of those brackets, because that works to show that when x is 1, that bracket is 0, and the whole equation will be 0. Now, I know that looks somewhat simple, because the first one we tried actually worked. If that didn't come out as 0 here, when we plugged in 1, then you could move on to the next factor of 12. So just try 2, try 3, try 4, try 6, and finally try 12. So let's say x equals 1 didn't result in 0, and then we tried 2, and we said, okay, x equals 2, so f of 2 equaled 0 when we tried that. Then we would know that x minus 2 is a factor. So that's another example. Or if we tried negative 3, which is also a factor of negative 12, and that came out as 0, then we would know that x plus 3 would be a factor. So finding that first initial factor is super key, because now we're just going to move into long division and factor the rest. Okay, so continuing on, we've already said that x minus 1 is one of the factors. So we want to factor the rest of the equation. So I'm just going to do long division to do that. Hopefully long division is familiar with you. If not, follow these steps and hopefully it'll work out okay. So I'm going to take the x into x cubed, and that goes in x squared times. Now I multiply the x squared back to the x minus 1 out front here, and I get x cubed minus x squared. When I subtract this, I get 0. Minus 9x squared minus negative x squared is minus 8x squared, plus 20x. We'll bring that down. Now do the same thing. Now the x into the negative 8x squared goes negative 8x times. Multiply it back. We get negative 8x squared plus 8x. And then we're going to subtract. And we're subtracting all of this. So we get 0 here. And 20x minus 8x is 12x, positive. Bring down the minus 12 from above. Do it one last time. X into 12x goes plus 12 times. And if you multiply this back the last time, we'll get 12x minus 12, and it'll all cancel out to 0. So what we found there, then you kind of focus on the top. And this is our result when we divide x minus 1, which again, we know x minus 1 is a factor because we plugged in 1 for x and got 0. So we can now say that our initial function, x cubed minus 9x squared plus 20x minus 12, can be rewritten as x minus 1 into x squared minus 8x plus 12. This is the same expression. We've just used long division to get it in factored form here. Now we can fully factor the second bracket. And this is just basic trinomial, so we need two numbers that multiply to 12 and add to negative 8. Multiply to 12, add to negative 8. And we'll get our two brackets that way. Those two numbers are negative 6 and negative 2, because those multiply to 12, add to negative 8. So we have x minus 2, x minus 6. And this is what f of x equals. So x minus 1 times x minus 2 times x minus 6 is the same function as our original. It's just in factored form instead of it all being multiplied out. The reason we like it in factored form is because, as we said, we want to set f of x equal to 0. So 0 equals x minus 1, x minus 2 times x minus 6. Again, factored form is perfect when we're setting it equal to 0, because now we just have one bracket times another bracket equals 0. And in order for that to be true, one of the brackets needs to be 0. So to have this first bracket equal 0, we know x equals 1. We've already got that as a solution. To make the second bracket 0, x equals 2. Or for the third bracket to be 0, x equals 6. So we know that if x equals 1, y is 0. If x equals 2, y is 0. Or if x equals 6, y is 0. So those three, 1, 2, and 6, are our x-intercepts for this question. I know that got a little messy, but let's quickly review the steps. Okay, so if we're looking at the steps when we're given this cubic function and we're looking for the x-intercepts, one, we want to use the factor theorem. And what the factor theorem says, but it says that if f of a, let's call it, equals 0, then x minus a has to be a factor. And how do we choose our a's, or our values, to actually test in the original equation? We look at that last constant and we take factors of it and plug it in. So again, for negative 12, the factors of it are 1, 2, 3, 4, 6, and 12. We could have tried any of those in for x here in the equation, solved it, and the one that comes out as 0, that sets up our first factor. Then we can say use long division to find other factor. this will probably be, well, this will result in a trinomial. Much like we factored and we got here, we got that, or I'm sorry, we did long division and we got x squared minus 8x plus 12 as the result in the long division. So we knew that that was the other bracket when we were going to factor the original function. Third step, we fully factored the trinomial. So that's your basic grade 9 factoring when we took this three-termed bracket and we broke it into the two brackets below, x minus 2 and x minus 6. Then solve x-intercepts as x values that make each bracket equals 0. So again, we set f of x equal to 0, and that was only going to be true if x was 1, because that made the first bracket 0, or if x was 2, which makes the second bracket 0, or if x was 6, which makes the third bracket 0. And those are your answers. Hopefully this was helpful. It requires good factoring skills, as well as long division, which is sort of old school but can be done pretty quickly. And then it also helps to do some quick mental math when you try 1 in for the equation. If that weren't to work, you'd have to do 2. But usually 1 is a pretty quick and easy way to do it. Please let us know if you have any other questions. Thanks.